Peace be upon you. Welcome to all my students in Period 2. Mr. Mohammed Omar with you. Okay, please listen to me carefully. We have studied before the first unit in geometry, and now we will study the second unit. The second unit in geometry is similarity and projection. In this unit we have 5 lessons. The first lesson is similarity. So in this video we are going to talk about the similarity. I hope everyone benefits from this video. Okay, in the beginning, what is the meaning of similarity? Similarity means likeness or sameness, and the concept of similarity is used many times in our daily life. For example, when you take a photo for you with a camera, then your photo appears on the screen as a minimizing. In this case, it's clear that your photo is similar to you. In this lesson, we will talk about number 1, similarity of two polygons, and number 2, similarity of two triangles. So let's start with similarity of two polygons. The definition is, it said that two polygons of the same number of sides are similar if the following two conditions are verified together. Number 1, their corresponding angles are equal in measure. Number 2, their corresponding sides lengths are proportional. So we have two conditions. It must verify together to can say the two polygons are similar. To understand the previous definition, look at the opposite figures. We have two polygons A, B, C, D and X, Y, Z, L, where number 1, measure of angle A equals measure of angle X, measure of angle B equals measure of angle Y, measure of angle C equals measure of angle Z, and measure of angle D equals measure of angle L. It means that the measures of the corresponding angles are equal. So the first condition is verified. And number 2, the side lengths of AB over the side lengths of XY equals BC over YZ equals CD over ZL equals DA over LX equals constant ratio. It means the lengths of the corresponding sides are proportional. So the second condition also is verified. Then from 1 and 2 we deduce that the polygons A, B, C, D is similar to the polygons X, Y, Z, L. And we denote it to the similarity by this symbol. Okay, now we have some important remarks. Remark number 1. Remark number 1 means there are 3 cases of constant ratio. Number 1, if the constant ratio is greater than 1, then the polygon B1 is an enlargement to the polygons B2. It means that when we prove the second condition in similarity and we found the result of constant ratio is 2, 3, 4 and so on, any number greater than 1, then we deduce that the polygon B1 is an enlargement to the polygons B2. And if the constant ratio is less than 1, then the polygon B1 is a minimizing of the polygons B2. Number 3, equal to 1. It means if the constant ratio is equal to 1, then the polygon B1 is congruent to the polygon B2. Remark number 2. In order that two polygons are similar, the two conditions should be verified together, and verifying one of them only is not enough to be similar. For example, in the opposite figure, the square and the rectangle are not similar polygons, although the measure of their corresponding angles are equal. Each of them is right angle, but their corresponding side lengths are not proportional. Also, the square and the rhombus are not similar polygons, although their corresponding side lengths are proportional, but the measure of their corresponding angles are not equal. So the square and the rhombus always not similar. Remark number 3. The congruent polygons are similar but it's not necessary that the similar polygons are congruent. Remark number 4. All regular polygons of the same number of sides are similar. For example, all squares are similar. Remark number 5. If each of two polygons is similar to a third polygon, then they are similar. Remark number 6. The order of corresponding vertices should be kept in given names of similar polygons, that to help us finding the proportional side lengths and the equal angles in measure. For example, in the opposite figure, we note that the vertex A is opposite to the vertex X. It means the measure of angle A equals to the measure of angle X. And the vertex B is opposite to the vertex Y. It means the measure of angle B is equal to the measure of angle Y, and so on. Also, I can get the proportional side lengths from this order, because AB is opposite to XY, and BC is opposite to YZ, and CD is opposite to ZL, and AD is opposite to XL. So AB over XY equals BC over YZ equals CD over ZL equals DA over LX. So now it's very easy to get the corresponding angles and the corresponding side lengths without look at the drawing. Okay, let's take example. In the opposite figure, the polygons A, B, C, D is similar to the polygons X, Y, Z, L. Find the measures and lengths of the unknown elements in the two polygons. Also find the ratio of enlargement. So now what's the given? The given is we have two similar polygons and the side length BC equals 2.5 centimeter and the side length DA equals 3 centimeter. XY equals 3 centimeter. YZ equals 1.4 centimeter. ZL equals 1.8 centimeter. And the measure of angle C equals 135 degree. The measure of angle A equals 70 degree. The measure of angle Y equals 65 degree. This is only given. And what is the RTF? The side length AB and the side length CD and the side length XL. And the measure of angle D, the measure of angle B, the measure of angle X, the measure of angle L, and the measure of angle Z. So let's prove. Okay, in the beginning, remember remark number 6 to get the corresponding sides and the corresponding vertices easily. So, since the polygons ABCD is similar to the polygons XYZL, then the measure of angle A equals the measure of angle X equals 70 degree. And the measure of angle B equals the measure of angle Y equals 65 degree. And the measure of angle C equals the measure of angle Z equals 135 degree. And we know that the summation of measures of the angles of the quadrilateral equals 360 degree. So the measure of angle D equals the measure of angle L equals 360 degree minus open bracket and write 70 degree plus 65 degree plus 135 degree equals, by use calculator, 90 degree. This is first required. And since the polygons ABCD is similar to the polygons XYZL, then AB over XY equals BC over YZ equals CD over ZL equals DA over LX. Now, by substitution about the given of side lengths, we can get the others. Then AB over 3 equals 2.1 over 1.4 equals CD over 1.8 equals 3 over LX. Now, by using the property of the proportion, that the product of the extremes equals the product of the means, then we can find the unknown sides. Then AB equals 4.5 centimeter and CD equals 2.7 centimeter and LX equals 2 centimeter. And the ratio of enlargement, it's the constant ratio among the length of the corresponding sides equals 3 over 2, and this is the second required. From the previous example, note that if we get the perimeter of the first polygons ABCD and the perimeter of the second polygons XYZL and then make division between them, then the result is the ratio of enlargement equals 3 over 2. So it means the ratio between two perimeter of two similar polygons equals the ratio between the lengths of the two corresponding sides. Second, similarity of triangle. Definition is: two triangles are similar if there exists one of the following conditions. Number 1, the corresponding angles are congruent. Number 2, the corresponding sides are proportional. So, there are different between the similarity of two triangles and the similarity of two polygons, because in the similarity of two polygons the two conditions must be verified together, but in the similarity of two triangles one of them enough to make the two triangles are similar. Okay, this is number 2. Okay, my dear student, this is important remarks about similarity of two triangles that we should know it. Number 1, the two right angle triangles are similar if the measure of an acute angle in one of them is equal to the measure of an acute angle in the other. Number 2, the two equilateral triangles are similar. Number 3, the two isosceles triangles are similar if the measure of an angle in one of them equals the measure of the corresponding angle in the other. Example number 2. In the opposite figure, ABC and EFD are two triangles. In them, measure of angle B equals measure of angle F equals 115 degree. Measure of angle A equals 22 degree. Measure of angle D equals 43 degree. The side length of AB equals 9 cm, BC equals 5 cm, AC equals 12 cm, and AD equals 18 cm. Find the length of each of the line segment EF and the line segment FD. Let's solve together, but before solve, pay attention with me now. To get the unknown side lengths, we must use the second condition in the definition of similarity of two triangles, that the lengths of the corresponding sides are proportional. But we can't use this condition without proof that the two triangles are similar. So, first of all, prove the first condition of the similarity of two triangles, that each of corresponding angles are equal in measure, to prove the similarity of two triangles. So let's get the unknown angles. We know that the summation of measure of the anterior angle of a triangle equals 180 degree. So in the triangle ABC, the measure of angle C equals 43 degree, and in angle DEF, the measure of angle E equals 180 degree minus 43 degree plus 115 degree equals 22 degree. Then we deduce that the measure of angle B equals the measure of angle F equals 115 degree, and the measure of angle C equals the measure of angle D equals 43 degree, and the measure of A equals the measure of E equals 22 degree. Then the triangle ABC is similar to the triangle EFD. And now we can use the second condition. The second condition is AB over EF equals BC over FD equals AC over ED. By substitution and use the properties of proportional, we can get the line segment EF and the line segment FD. Then the line segment EF equals 13.5 centimeter and line segment FD equals 7.5 centimeter, and this is the required. Now we are finished our lesson. Thanks a lot for listening. Goodbye.